Hello, my name's Al Basterfer. This short presentation is to introduce you to the RCCD control. The RCCD control consists of three components. You have the hot gas modulating valve, a de-superheater valve, and an atomizing chamber that happens to be patented. The whole control is patented. The RCCD control is a backward sensing control device that when a drop in suction pressure is noted, it will bypass hot gas into the suction line to stabilize the pressure. This is accomplished while maintaining proper superheat to the compressor. This is not hot gas. Hot gas loads the evaporator. This unloads the compressor. Thus, basically, it is a modulating unloader for a fixed capacity compressor that matches the capacity with load. Benefits of the RCCD. It extends the runtime. That is critical. It prevents short cycling. That saves equipment. By limiting the starts, you'll have extended life. Provides humidity control. By raising the saturated suction pressure, it allows for extended runtime, which we know will help control humidity and was seen in the next slide or two. Prevents liquid slugging. With a TXV valve in place, it only sees superheat, but with a fixed orifice or something as a fixed orifice, what you'll end up having is that you could have slugging because the superheat's depending on the load and the charge. And when the load goes away, the superheat goes away. This here maintains it. Changes the sensible to latent relationship of the evaporator. That is in percentage terms. There is only so much latent removal an evaporator can do, but what this does is when it unloads and there's a presence of high humidity, this causes it to unload sensible rather than latent energy. Provides evaporator control. Again, this is to control the evaporator and to help out with that. Whereas we have head pressure control for the condenser, this is now evaporator control. Helps out with low ambient. Because it sees a drop in suction pressure and bypasses, you'll have issues. You'll eliminate many of your issues with kicking out on low pressure switches. Prevents evaporator freezing. This is because it maintains the evaporator the evaporator pressure above freezing or the temperature above freezing plus much more. This is out of an article from ASHRAE from 2011. And what it shows is runtime versus useful moisture removal. You have to have a certain amount of runtime before any moisture gets out of the system to the drain pan and out. And that's the useful moisture removal. If you don't get the minimum runtime, what happens is it evaporates right back in. So you're basically wasting energy because that evaporation also does cooling. So you'll be wasting energy. If you'll notice, coil number 2 is what I consider a normal coil for HVAC equipment. That takes a minimum of 16.3 minutes for that moisture to build up on the coil, get down to the drain pan, and get out. So I always tell everybody you need at least a minimum 15-minute runtime to do any dehumidification. Anytime it shuts off before that time, nothing's done. You just wasted all that energy. The RCCD device will actually do a little bit to improve your efficiency of your unit, and that's discussed in great detail on other presentations. Applications are numerous. Basically, every unit could use an RCCD control. Whether they want to put on it or not, it could use it. MCC rooms, control rooms, operating rooms. One thing about operating rooms is they run at a certain temperature. So whenever you try to run the HVAC DX equipment at those temperatures, you just can't do it. A good example is a standard desiccant unit will go down to about 41 grains. An active desiccant unit will go way down. But an active desiccant unit is something that takes a lot of energy to operate and cost a lot. You can actually do operating rooms with an RCCD control and get it down to about 38 grains of moisture. Clean rooms, data rooms, and closets. A lot of times they throw an air conditioning unit into a data room, and that it's not designed to do any dehumidification. VAV and VVT systems. Thing about that is as the VAVs close off and you reduce the airflow, if you don't have something taking care of the capacity on the unit, you have issues. Geothermals. They are designed for loads in the north for the heating loads. When they go on the cooling load, they're extremely oversized. Large outside air applications, normally up to 60%. After that, you got to have some kind of reheat, but it make up air units, chillers, many more. It's pretty easy to design and select the system, but on this particular chart, I want you to notice that over on the side, on the left-hand side, it says system or circuit tonnage. That means if you got more than one circuit, you can work with it. There is so many variable and flexible applications of this control, it's not even funny. That's why this is just a high level. But what I'm showing you is that you can give yourself a lot of capacity control. 10 tons is not the limit on it. It can go higher. Remember, a lot of systems, like a 20-ton package unit, could have two 10-ton compressors. So now all of a sudden, that 20-ton package unit with a 5 on it, giving you what is there, 7 tons of modulation. Now you're able to go from basically 3 tons to 20 tons with just a little bit of a gap in between. Limited stock for those that will want to stock this. Only 4 models. And with head pressure control, you have 16 different fixed capacities. With head pressure control, variable capacity from 1.6 tons to 7.11 tons. That is the amount of modulation. That is not the size of the unit. Replacement options. If you were out of the 410-5 and needed 5 tons of modulation, you can use the 410-3 plus a head pressure control. All this is contained within the specification sheets, which you'll see the example of one a little bit later. General information, space, dry bulb, wet bulb, the RH, just everything there is, equipment, building information, area information. The more information is the better, but in general, the thoughts are just say you got a 5-ton package in it, you'll put a 410-3 on it and go from there. Normally, 80% of the time, the application of the valve's all you need. Sometimes you may have to put other items on, such as a humidistat, fan control, head pressure control. Something may have to be added, but all that will be discussed in much more detail in following videos. Selection criteria: system or circuit tonnage, operating range, space relative humidity over a period. In other words, if it's 85%, you got a huge issue. Cycling conditions: how many times does it cycle an hour, and how long does it stay on? The duty cycle during the worst period, I've seen them cycle on for 3 minutes and kick off. Evaporator selection: this can be critical because if you got a package unit that has what they call, or a split system, a split face evaporator, there's other things you have to do, and you may have to add 2 valves. Golden rule: suction gas velocity. That previous screen that showed that previous screen right there, you'll see on this that it will say maximum suction riser. That is because we have to maintain 1,000 feet per minute in that riser. Miscellaneous information: tandem compressor connected to the manifold area. Nothing external. Know the sequence of operation. There is actually some equipment out here that brings on a very small first stage compressor, then shuts it off and brings on a larger second stage, then brings the first stage back on. In that case there, you would want to put the control on that second stage. This is the 410-3. Just to point out some things, the lower left-hand corner, you'll see bypass capacity at different condensing temperatures. What you will notice is that at 68 degrees, this thing will bypass 3.24 tons. Now, 68 degrees would actually be about a 50 to 55 degree outdoor air temperature. And 104 will probably be about a 84 to 90 degree outdoor air temperature. This is the condensing temperatures inside the condenser. Another thing I would like you to notice is that you'll see this thing, it says low pressure adjustment. Yes, that is on a valve coming from the hot gas line, but you're adjusting your saturated suction, low pressure at that point. Also, you'll notice the compressor discharge line, liquid line, the suction connection down there. That suction connection down there is a 1/2 inch ID or 5/8 OD. The reason it's set up like that is if you want to put a 5/8 ball valve on there, you just slide it over it. Or if you need to go a little bit of a distance, you can put 1/2 inch line in there. It just makes it easier. It gives you some advantages. Also, you'll see that there is 2 bulbs. The valves look identical. They're not identical. The TXV, the liquid injection adjustment, you will not touch it. That remains to be. You don't bother. You don't touch it at all. The hot gas, all adjustments done on the valve that enters the side of the unit. Another advantage of this valve over another competitor is it has multiple mounting position. This is a flow-through valve. In other words, it comes out the bottom. It doesn't come out the top, but you can actually lay it on its side. You can have multiple mounting positions. That is all discussed in a more detail in other videos. It's mounted in the condenser section. One thing that needs to be known and said all the time, this valve right here, the ball valve between the discharge of the valve and the suction T has to be in place. It can be installed in heat pumps. Critical point there is look where the suction line's connected. It's between the reversing valve and the indoor coil. If you connect it between the reversing valve and the compressor, whenever you're trying to heat in the wintertime, the colder it gets outside, the less you're going to have because it's going to keep unloading it and taking the energy away from the house. It can go on multiple compressors, and a lot of times you'll see the note number 1. It says location if solenoid is needed. There's instances where you may have 40-ton package in it with 4 10-ton compressors, and your issue ain't with the bottom side, it's within between the stages. You put the valve in, and then what you'll do is you'll activate that solenoid when the second stage comes on. And what that does is that, yes, 10 tons is 25%, but now you've got modulation of the 7 tons between stages, which helps out with humidity control and also keeps you from short cycling the compressors in between stages. Remember the humidity ratio. What I'm talking about here, and I'm going to go through this really super briefly, is that whatever the temperature is that you're desiring inside has a humidity ratio on the psychrometric chart. So if you're desiring a 55 degree, 50% RH condition, that means that your humidity ratio, if you're desiring a 75 degrees, 55%, 50% RH, that means your dew point is 55 degrees. So your coil temperature has to be below 55 degrees. So with that said, and you're sitting there, the adjustment of this valve is determined on the humidity ratio. So you can adjust it all the way up to the top and maintain what you're trying to do. That, again, will be gone into in much more detail in later videos. Example of one installation that occurred, and I have all the information on this. The customer decided to put a logger on 21st and 22nd before they installed the valve. On the 23rd, they installed the valve. On the 24th and 25th, they did a logger reading again. Their dates are just a little bit off, but I know this for a fact that this happened like this. If you look at the humidity on those dates, the 21st and 22nd, is not much difference than the 24th and the 25th. But what you're going to find out is that there was a huge difference in results. For the RH is the yellow line at the top. And it's a little bit hard to see, but I can't change it because it's from the logger. If you look at the scale over there, this RH actually ran from 72 to about 74%. Sometimes it got a little bit longer down there, but that's also, if you look, they had the temperature, the cooling on quite a bit longer. But if you it ran from 72 to 74%, sometimes touching 80%, but that's where we're at. Now the temperature is at kind of a reddish colored line running across the center there. And that temperature averaged about 72 degrees. And the dew point, the average dew point was around 63 degrees. That was before they put the RCCD on. When they installed the RCCD, they did the take afterwards. And if you look at the RH scale on the right-hand side, it's way down. It's a lot different now. Now we're looking at an average RH in a space of 44%. Our temperature is pretty much up and down a little bit, but it's averaging out to about 72 where it was at. But also now the dew point's around 48 degrees. That happened, and I have the young man's name in that. That happened the 2 days after the RCCD was installed. This is another one from another customer. He actually installed the RCCDs in an issue and convenience stores in Texas. They had a huge problem, and it speaks for itself. The RCCD is patented, and the patented came about August 25th of 2020. I am not the patenting person. I'm not the designer. I'm not the engineer. I had nothing to do with it, but I do know how systems work. And a previous company that I worked with had a product that was similar to the RCCD, but not quite as advanced. So it is a patented item. This is the internal parts of the RCCD. If you look on the right-hand side, that is a specialized valve that's designed for hot gas bypassing. The 3A that's labeled there on this particular valve was the inlet, because this was a 410-5. Now, just the opposite, the 3A and the 3F is changed on the 1, 2s, and 3s. That is discussed at much more detail in later videos. The 3C, that bulb is not a sensing bulb, it's a reservoir. It can be fastened to anything except for something that gets extremely hot, like a hot gas line. But a lot of times on an external equalizer, which is the 4, that's where we put it. On the the 410-1, it does not have an external equalizer. So I recommend that you put some silicone on above it, take a tie wrap, and just tie wrap it right to the top of the valve. The chamber itself is patented. The fill inside there is a specialized fill, but the very top is really what makes this thing works. It's an atomizing chamber at the top. And at the top, the hot gas comes in, preheats the tube, and then as the liquid comes in to de-superheat, that liquid's flashed up there, and that chamber ensures that only cool gas gets back to the compressor. It's been tested and designed many different ways. The up at the top coming in is a de-superheater valve, which is simply a TXV that shuts off pretty much 100%. And that valve there does have a sensing bulb, and it can be fastened to the body of this device. Unlike a previous device where you got to take the bulb down to the suction line, what happens in the top 25% of this valve, it takes the whole other valve, the whole valve for it to happen there. So this only has 3 connections. So that makes it pretty easy. 2A is an adjustment port that no one needs to touch unless they're in direct contact with myself or somebody that knows a lot more about this device. That can actually be detrimental to the system if the adjustment is done improperly. This is an exploded view of that top area. And what it does, it shows that it has some holes down below. And as the gas comes in, it filters in. This small area in between here, 23C, is where everything takes place. Then 23D is where the cool gas exits. Not the end, but the beginning. I provide training to all technicians through a YouTube channel. I'm going to be putting all this stuff on a YouTube channel, and I'm going to be continuing to develop training videos and other videos that is in association with this valve and how to use this valve. So I thank you for your time. There's my address for the YouTube channel, which if you're watching this, you probably are on it. So take care and have a wonderful year.